Hello mga ka-tribes! Welcome to Daddy Brew TV. This is your adventurous math teacher. For today's video, let's have Chapter 1, Lesson 1, representing real-life situations using functions. Okay, welcome to the first lesson of your general mathematics. This lesson will give you the practical application of functions in a real-life scenario, including the piecewise function. When you are in grade 8, you already encountered relation and function. But in this video, let's take into a deeper sense on how this topic can be used in our daily life. Are you all ready? Okay, so what's in this video lesson? Before we proceed in representing real-life scenario using function, let's go back to where we start. What have you remembered about relations and functions? So let's define a relation. A relation is any set of ordered pairs. The set of all first elements of the ordered pairs is called the domain of the relation. And the set of all second elements is called the range. Okay? Take note, a relation is any set of ordered pairs. Now, what about a function? A function is a relation or rule of correspondence between two elements, the domain and range, such that each element in the domain corresponds to exactly one element in the range. To further understand function, let's study the following. Given the following ordered pairs, which relations are functions? Now, for the ordered pair A, we have 1, 2, 2, 3, 3, 4, and 4, 5, or 4, 5. Now, try to examine the first element of the given ordered pairs. These are 1, 2, 3, and 4. Now, question. Does each of the first element repeated? None, right? So therefore, this relation is a function. Okay, next, relation B. Observe the first elements. That's your clue. So the first elements in the given pairs are 3, 4, 5, and 6, none of which are repeated. So again, this relation is a function. Now, what about C, relation C? We have the ordered pairs 1, 0, 0, 1, negative 1, 0, and 0, negative 1. As you notice, 0 is repeated. It is not unique anymore. So therefore, this relation is not a function. Now, for relation D, we have AB, BC, CD, and AD. Again, A is repeated. So it is not unique anymore. So it is not a function. Okay? So in general, for you to determine if the given ordered pairs or relations is really a function, just observe the first elements. Make sure that none of which is repeated or more than once. Okay? Next, what about if the given is a table of values? Okay? Now, table A, we have the values of x such that 1, 2, 3, 4, 5, and 6, whose pairs are the values of y, which is 2, 4, 6, 8, 10, 12. Again, same rule to follow likewise in the given ordered pairs. Observe or examine the first elements. 1, 2, 3, 4, 5, 6. So none of which is repeated. They are all unique, so therefore this table of values is also a function. Now for table B, observe the first element, the values of x. 4, negative 3, 1, 2, and 5. Again, none of which are repeated. So it is also a function. Now, what about table C? We have the first element 0, negative 1, 4, 2, and negative 1. Take note, we have a repeated first elements, which is negative 1. So again, negative 1 is not unique anymore. So therefore, the table of values is not a function. Okay? Next. We can also identify a function given a diagram. On the following mapping diagrams, which do you think represent functions? Okay, let's consider diagram A, whose domain are A, B, and C, and range are x and y. Now, observe the pairings if there is a unique first element. Now, domain A is paired to x. Domain B is paired to y. And domain C is paired to y also. Now, the condition is just examine the domain or the first element of the mapping diagram or the values of x. If none of which are repeated, then it is also a function. So as you can see, A, B, and C are unique. It is not repeated. So therefore, mapping diagram A is a function. Next, mapping diagram B. The domains are x and y, and the range are A, B, and C. Now, x is paired to A, and x again is paired to B, and y is paired to C. What do you notice? The first element x is repeated. It is not unique, so therefore, this mapping diagram is not a function. Okay? Third example. The domains are Jana, Donna, and Maya, and the range are Ken, Mark, and Ray. Jana is paired to Ray. Donna is paired to Mark, and Maya is paired to Ken. Are the first element or domain repeated? No, right? They are all unique. So therefore, this mapping diagram is also a function. Next, how about if the given are graphs of relations? Can you identify which are functions? Do you still remember the vertical line test? Okay, let's recall. A relation between two sets of numbers can be illustrated by graph in the Cartesian plane, and that a function passes the vertical line test. Okay, a graph of a relation is a function if any vertical line drawn passing through the graph intersects it at exactly one point. Let's try. Let's have example number 1. Okay, given the graph or a line, the graph of a linear function. Now, let us use the vertical line test to identify if this graph represents a function. Again, let's draw a vertical line and observe their intersections. How many intersections are there? There is only one, right? So it satisfies the definition. So therefore, this graph is a function. Okay? Next example. If the graph is an ellipse or oblong, let's draw again a vertical line test to prove if it is a function or not. Say the vertical is here. Observe that it intersects twice at the ellipse or oblong. So therefore, this graph is not a function. Okay? In mathematics, we can represent functions in different ways. It can be represented through words, tables, mappings, equations, and graphs. So we have already discussed, or I already represent you tables, mappings, and graphs. Now, next, what about words and equations? We said that for a relation to become a function, the value of the domain must correspond to a single value of the range. There is the input and the output relationship. Take note, there is an input and output relationship. So let's read the following situations that show function. Situation 1. Mark went to 812 store to buy some soda. He puts money, punches a specific button, then the soda drops from the slot machine. What is the function rule? Now, the function rule is the product price. And what is the product price? Now, the input or the domain is the money used by Mark, right? Combined with selected button, while the output or range is the product. This is also show a one-to-one correspondence or a specific amount corresponds to a specific product. So therefore, the function rule is the product price. Okay? Second situation. Mr. Marquez, a mathematics teacher, asks his students to measure the diameter and circumference of several round containers or lids and record the data in a table. What do you think they would discover? And what is the function rule? Now, the diameter and circumference relationship is a function. The diameter is the input, while the circumference is the output. So what is now the function rule? Observe that as they divide each circumference by its diameter, they would notice a constant ratio, which is a rough approximation of pi. Okay? And a pi in symbol is approximately equal to 3.1416 and so on. Okay? And that is what they discovered and the function rule. Next, let us discuss or describe the function machine. Function can be illustrated as a machine where there is the input and the output. When you put an object into a machine, you expect a product as output after the process being done by the machine. For example, when you put an orange fruit into a juicer, you expect an orange juice as the output and not a grape juice. Or you will never expect to have two kinds of juices, orange and grapes, right? Okay, in the given illustration, we have the inputs and a function machine. Inside the function machine, it will process, then we have an output. Okay, so that is the meaning of the function machine. Now, you have learned that function can be represented by equation. Since output y is dependent on input x, we can say that y is a function of x. Again, take note, the output y is dependent on input x. Okay? For example, if a function machine always adds 3 to whatever you put in it, therefore, we can derive an equation of x plus 3 is equal to y, or the function of x is equal to x plus 3, where f of x is equal to y. Okay? Next, let's try to create equations using the following situations. Situation A. If height is a function of age, give a function that can represent the height of a person in age. If every year the height is added by 2 inches. Now, for our solution, since every year the height is added by 2 inches, the height function is denoted by h of a is equal now to 2 plus a. And that is our function or an equation. Okay? Next, situation B. If distance is a function of time, give a function d that can represent the distance a car travels in t time. If every hour the car travels 60 kilometers. So for our solution, since every hour the car travels 60 kilometers, therefore the distance function is given by the equation d of t is equal to 60t. And that is now our equation or function. Now, let's talk about piecewise functions. There are functions that requires more than one formula in order to obtain the given output. There are instances when we need to describe situations in which a rule or relationship changes as the input value crosses certain boundaries. In this case, we need to apply the piecewise function. And what is a piecewise function? A piecewise function is a function in which more than one formula is used to define the output. So each formula has its own domain, and the domain of the function is the union of all these smaller domains. We notate this idea like this. F of x is equal now to Formula 1 if x is in domain 1, Formula 2 if x is in domain 2, and Formula 3 if x is in domain 3. Okay? Now, let's have an example. Example A. A user is charged 250 pesos monthly for a particular mobile plan, which includes 200 free text messages. Messages in excess of 200 are charged 1 peso each. Now, represent the monthly cost for text messaging using the function T of M, where M is the number of messages sent in a month. So for our solution, the function T of M is equal to, there are two possible equations, 250 if M is between 0 and 200 inclusive. This is for sending messages of not exceeding 200. And the second equation is equal to 250 plus M if M is greater than 200, in case the messages sent were more than 200. Okay? So this is now our piecewise function. Take note, there are more than one equation. Okay? Now let's have example letter B. A certain chocolate bar costs 50 pesos per piece. However, if you buy more than 5 pieces, they will mark down the price to 48 pesos per piece. Use a piecewise function to represent the cost in terms of the number of chocolate bars bought. Now, for the solution, the piecewise function is denoted now by f of n is equal to 50 pesos if n, the number of chocolate bars, is between 0 and 5 inclusive. Okay? This first equation is for buying 5 chocolate bars or less. And the second equation is 48n if n is greater than 5. That's for buying more than 5 chocolate bars. Okay? So thank you for watching. See you on my next video. Bye!